Okay. Last time we talked actually about factors and multiples, and we did a few questions, as you remember. We did this question, find the smallest value of k, example 1 and example 2, and we did these questions together. Okay, and evaluate each of the following using a calculator. And also you need to practice solving some questions using a calculator. Using a calculator, a lot of students say that, oh, calculator, I can do everything. It's not like that. Okay, using a calculator and wisely, also you need to have some skill and experience, right? For example, as you see in question D, and the whole expression, can you just input the whole expression into the calculator, and after that click equal sign and get the answer, not one by one. Okay, so and also we need to be able to calculate using calculator fast. Anyway, you will do this yourself, but from here we will continue. Let's say a few questions, and after that I will finish this chapter. Okay, let's continue. Selen, you read the question. After that, we will discuss this, and you tell me the idea. We will solve this, and everything's okay. We will move to the next question. Okay, read the question.
John, Peter, and Paul were each given a piece of string of equal length. John cut his into equal lengths of 2 meters. Peter cut his into equal lengths of 3 meters, and Paul cut his into equal lengths of 5 meters. If there was no remainder in each case, find the shortest length of string given to each of them.
Okay, to solve this question first, usually this kind of question we need to draw a picture, right? So we are talking about 3 people. Let's say you are talking about the first guy, John, a second guy, Peter, and third guy, Paul. And everybody has a piece of string, and they have the same length, and the lengths of these strings are the same, right? So that we can actually visualize what's going on here. It says that John cuts his into equal length of 2 meters. So he actually cut into some, right? I don't know how many pieces, but each one is 2 meters. And Peter cut his string into equal length of 3 meters. And this one is a bit longer, 3 meters, and 3 meters. Each piece is 3 meters. And Paul cut his string into equal length of 5 meters. This one is a bit longer, how many pieces we don't know, but we know that it's 5 meters. What is the question? It says that when they cut this, actually, if there was no remainder in each case, that means that John cut his string into exactly, what is it? The some number of small pieces, right? That one is, we don't have any remainder. That means that every piece length is 2 meters, 2 meters, 2 meters, 2 meters. We don't have any piece that is different from 2 meters. That means that without without leaving any remainder. In the same similar way, the second guy and third guy, the question is find the shortest length of string given to each of them. So what do you think? How can we solve this question? How do you solve? What method should we use to solve this problem?
Maybe multiply all of them and divide by 3, but I have no idea.
No. Here, Salim, is about, I think, it gives us ideas about least common multiple, right? So the length of this string, actually, this one is, I don't know, let's say it is A meters. Also the second one, let me just write here. What is the length of the first string? Let's say it is M, not M, let's say L meters. The second one also L meters. And the third one is L meters. As you see here, since actually no remainder is left, when we just cut into equal length of 2 meters, right? That means that this L, it must be divisible by 2. And also at the same time, when we just cut this string into equal length of 3 meters, we have no remainder. That means that also this L must be divisible by 3. And also at the same time, when we just cut this, because all the strings have the same length, right? When we just cut this into equal length of 5 meters, again, we have no remainder here. That means that also this L, right, the length of the string it must be divisible by 5. Like for example, if it is 10, I can cut into 2 equal pieces, right? Each one is 5 meters. If it is 15, 3 equal pieces. If it is 70, for example, we cannot do this. You can just cut into 3 equal pieces. Each one is 5 meters, and there will be short string left over here, right? So the question is find the shortest length. So that means that we need to look,
30.
actually find a number, and the smallest number that is divisible by 2, that is divisible by 3, that is divisible by 5. So that is the least common multiple of these
30.
numbers. So it is 2, 3, and 5. And all of these numbers are prime numbers, right? So that's equal to 2 times 3 times 5, which is equal to 30. So actually that guy or all of these people were given strings of length 30 meters, right? So John, right, actually he cut into 15 equal pieces.
15 parts.
And Peter 10, and Paul, it is 6. Okay. Let's see another question. Read the question.
What is the shortest length which can be divided into 4 centimeters, 8 or 2 centimeters portions without millimeters?
Okay. The
We need
similar
to
question, right?
find the LSM.
It's a similar question because it says, what is the shortest length? We are looking for something, a string maybe, and let's say this length is L meters. So actually, we should be able to divide into equal pieces, right, of 4 centimeters or 8 centimeters or 2 centimeters. And it says shortest. That's why we need to find that
32.
L must be least common multiple of 4, 8, and 2. What is it?
32.
Are you sure?
Maybe 28.
What is the least common multiple of 4, 8, and 2? How about 8? Why? How about 8? Why not 8?
Oh.
8 is divisible by 4, right? 8 is divisible by 8. 8 is divisible by 2.
Yes.
32 is too big. Even actually, you can say like 16 is okay. 24, but 32 is too big. So actually, how do you find the least common multiple of these numbers, right? Divide by 2, it is 1, 2, 4. Divide by 2, 1, 2. Divide by 2, it is 1. So the product of these numbers, 2 times 2 times 2, that's equal to 8. That's how we find the least common multiple, right? Okay. Next question.
Find two numbers if their LSM is 120 and their highest common factor is 4. Give 3 possible answers.
Yeah, find two numbers if their LCM is 120 and their ACF is 4. So that means that we are looking for two numbers. Oops. Let me change my marker color. So we are looking two numbers. What are those numbers? Let's say it is A and B. And I don't know these numbers. We are looking for these numbers. And here, what is given here? LCM of these numbers, A and B, that's equal to 120. And highest common factor of these numbers, right, that's equal to 4. And it says give 3 possible answers. Let's just do this mentally. Can you just tell me 3 different answers whose least common multiple is 120 and highest common factor is 4? How can we do that?
Divide
what by what?
120 by 4. Or
let me just write one formula here.
The most simplest.
Selim, before we continue, let me just write one formula here. A times B these numbers, right, is always equal to highest common factor of these numbers, A and B, times least common, least common multiple of these numbers. Is that right? Do you think it is true? For example, let me just tell you two numbers. For example, let's say 6 and 8. Not 6, 6 and 8. And what is the highest common factor of 6 and 8? Highest common factor and least common multiple. And what is the highest common factor of 6 and 8? It is 2. Right? The biggest number that divides both of these numbers, 6 and 8. What number is it? It is 2. Do we have any bigger number than this than 2? No. So 2 divides 6 over 2 equals 3. 8 over 2 is equal to 3. And also using that formula, I can find this is 6 and 8 divided by 2. It is 3. Here we have 4 is a common factor. Now divide by 2. It's not a common factor. 3, 2. Divide by 2. It is 3, 1. And divide by 3. It is 1. So highest common factor is only the common factor here. It is 2. Least common multiple, 2 times 2 times 2, 2 times 2 times 2 times 3, which is equal to 24. So least common multiple of this number equals 24. And this one is 2. What is 6 times 8, Selin? It is 48, right? On the right-hand side, what is 2 times 24? It's also 48. Right? So in general, it is true. If you're given two natural numbers, when we're actually talking about highest common factor or factors, we mean natural numbers. The product of these numbers, A times B, is always equal to highest common factor of these numbers times least common multiple of these numbers. Okay? Using this idea, this formula, now we will solve this question. Here, what is given here? LCM of these two numbers equals 120. And ACF of these numbers equals 4. So using this one, then what is, let's say, A times B? What is A times B? It is LCM times ACF, right? That's equal to 4 times 120, which is equal to 480. So now I can answer this question. Just can you tell me two numbers whose product is 480? And at the same time, highest common factor is 4. This common multiple is, what is it? 120. For example, let's say, for example, in how many different ways I can write this one? For example, can I write it as 10 times 48? I can, right? But 4 is not the highest common factor of 10 because 10 is not divisible by 4. It doesn't work. Okay. And how about 4 times 120? Right? Highest common factor is 4, right? Least common multiple is 120. This is the first choice. And another one, and the multiple of 4. For example, let's say, how about 8 times, because just take 120, I can write it as 2 times 60, 8 times 60. 8 times 60, is it 480? Yes. And what is the highest common factor of 8 and 60? It is 4, right? Because 8 is divisible by 4, 60 is divisible by 4, and we don't have any bigger number than 4 that divides both of these numbers. We have the first choice because we need to show three pairs, right? 3 possible answers. This one, the second one. And the third one is, how about if I just write it as 3? Let me just take 3 from here. It is 12. So here we have 12 times 40, right? And 12, 40, highest common factor is, what is it? It is 4. You can check this because 12 is divisible by, what are the factors of 12? It is 1, 2, 3, 4, 6, 12. Among these numbers, only 4 actually divides 12 and also 40. So we have 3 possible answers. What are these numbers? Let me just write here, dot, dot, dot. Those numbers are either 4 and 120 or 8 and 60 or 12 and 40. So actually we have shown three numbers. Ibrahim,
Okay.
are you there? Who are you?
Yes, teacher. My name is Ibrahim.
Can we see your face? Are you joining with
Yeah.
laptop or with telephone?
I joined my laptop.
Can I see your face?
Yeah. 1 minute. Oh, 1 minute. Can you see me?
Yeah, I can see you very well. Ibrahim, how are you?
I'm fine. How
So
about
this is
you?
your first class, right? And this is our first chapter, Ibrahim. Actually, in our previous class, we talked about, actually, we had class about factors, common factors, and highest common factor of two numbers and three numbers or any numbers, and also least common multiple of these numbers. Do you have any idea about these things, Ibrahim? Did you ever learn before?
Yeah. No.
Yes or no? So now you are in grade 7, right?
Yeah.
Okay. Ibrahim, now maybe this is your first class. Here we have 72 students, okay? We don't have a big classroom here, and this is a private math class. Anytime if you have question, if you don't understand anything, you should just stop and you can ask, okay? Otherwise, if I only
Okay.
talk and you listen and you don't ask question, our class, I mean, it will not be very efficient, okay? It will be like monologue style. I just talk, you listen, and I don't know, there will be no much outcome. Now, you don't understand, you can just stop. We are not in a rush, right? So we can have discussion. I can explain one more time. Still, if you don't understand, I can give you more examples, or you may have some different idea, okay? And also you can share your idea with us. Okay, Ibrahim.
Okay.
Ibrahim, actually, we have a group in WhatsApp, okay? And also you have to join this group. And after that, we will communicate with each other through that group. Okay, I will send assignments in that group. You have to receive it, take it, and do them, and submit also through that group. Okay, let's continue. Okay, Ibrahim, can you read the question?
Yes, I can. A three-digit number is a product of four prime numbers, given that the three digits of the number are all prime and different, and that the sum of its prime factors is 30. Find the number.
Okay. Usually,
Um,
we are not native speakers. You are living in Azerbaijan, right? And also I don't know, I'm Uzbek from Uzbekistan. So English is not our, what is it, first language. So when we just read the problem for the first time, we may not understand. We may understand, but we may not understand. When I'm teaching my students, I say them, okay, just read it quickly. You don't have to understand everything, okay? And when you just read very quickly, at least you have some idea what we are talking about, okay? And after that, the second time when you're reading, you need to hold a pencil, take a note, okay? Write down what is given here. And after that, you need to just make a connection with the variables in the problem or write the equation, and we try to solve it. So here, a three-digit number is the product of four prime numbers. Okay, we are talking about three-digit number. What are the three-digit number? Any number between 100 and 1000, right? And 1000 is not included. So let's say between 100 and 999. Right? All of these numbers are three-digit numbers. Three-digit number means a number which has three digits. It says that a three-digit number is the product of four prime numbers. Okay, given that the three digits of the number are all prime and different, and the sum of its prime factors is 30. Find the number. It's a bit challenging question. So here we are talking about a three-digit number. What is that? maybe it is something like this, 3-digit number A, B, C, right? What is A? Some kind of digits, B, C. Usually it's 3-digit number, we can show like this. If I say 1-digit number, you just say only A, right? If I say 2-digit number, maybe it is A and B, like this, because this bar means actually they are not multiplied, just 2-digit number. 4-digit number, maybe A, B, C, D. Okay, is the product of 4 prime numbers. Okay, that is equal to product of 4 prime numbers. Maybe here we have the first prime number, P1, times the second prime number, P2, and third prime number, P3, and fourth prime number, P4. 4 prime numbers, all are prime. Given that the 3 digits of the number are all prime, that means that also this A, B, C, they're also prime. And the difference, all prime and different. And that the sum of its prime factors is 30. Find the number. And the sum of its prime factors is 30. Okay? And find the number. Okay, so let's solve this. Now, second question for you. What can you say about this ABC? Given that the 3 digits of the number are all prime number, prime, okay? Can you give me some possibility that this ABC, how many prime numbers do we have that is less than 10? We have what numbers? Maybe it is 2, right? Maybe it's 3 or 5 or 7, right? Do we have any number less than 9 prime number? No, because these are ABC are digits, right? That means that A is either 2 or 3 or 5 or 7, one of these numbers, right? So this ABC maybe actually A is maybe 2, 3 or 5 or 7. B is maybe again one of these numbers. Anyway, and the difference. So they are all different. Okay. And the sum of its prime factors is 30. The sum of the prime factors is 30. Find the number. Do you want to try? It's a bit challenging question.
Two, 3, and 5, 235. Plus 2 by 3 is 6, and 6 by 5 is 30.
Oh, that's the last question. It should be 10. Okay. All right. I don't know, Stalin. It's a bit hard question. This should be the last question, actually. Yes, Stalin. Say again, do you have any idea? How do you solve this question? A 3-digit number is the product of 4 prime numbers. Okay. Given that the 3 digits of the number are all prime, okay, either 3 of this, and different, and the sum of its prime factors, the sum of its prime factors is 30. Right? So the sum of its prime factors, so it may be 532. But how many possible numbers we have? We have like maybe 532, 235. Okay, we have a lot of choices. I'm stuck. Okay, let's give a break. Okay, let me just think. Okay, and after we'll continue this. Before this, we have one question left. It's the last question. Usually the last 2 questions are a bit challenging question, because if you just keep thinking, we'll waste time. Let me try on the paper, and after that, we will do it again together. Let's just do this question. After that, we will have break, okay? 5-minute break. It is 9:34 already. So find the smallest value of k when 280k is a perfect number and 882k is a cube. Selin, do you remember we solved a similar question?
Yes, I do.
So can you tell me how do you solve this now? So we are assuming that this 280 times k, right? A perfect number. What does it mean? It is a square of some natural number, right? Here this m is a natural number. To do this one, we have to find prime factorization of 280. This 280. What is the prime factorization of 280? Divide by 2. Here we have 140. Divide by 2. Here we have 70. Divide by 2. Here we have 35. And divide by 5. It is 7. Divide by 7. It is 1. So here 280 times k, we can write it as 2 cubed times 5 times 7 times k, right? To be some number square, actually we need to have 2 squared, 5 squared, or the indices must be even numbers, right? So what must be the value of k so that when I just put the value of k here, this number becomes a perfect square? And actually it says the smallest value. Actually, we have a lot of numbers. So this k must have a factor of 2, right? And I need one more 5 here. If I put 5 here, it will be 5 squared. So also here we have 5. And here we need to also have 7. Actually, what is it? It is 70. As I see here, if I substitute here, what we have here? 2 cubed times 5 times 7. And what is the value of k? 2 times 5 times 7. 2 times 5 times 7. Now, if you simplify this, here we have 3 2's, one more 2. So this 2 to the power of 4. 5, 5, it is 5 squared. 7, 7, it is 7 squared. So now, can I just write it as, what is 4? It is 2 squared, right? So here we have 2 squared times 5 times 7. And here we have squared. And because here we have a squared times b squared times c squared, we can write it as a times b times c squared. That's the index is same, right? Also here we have 2 times 2. So which is equal to 4, 4 times 5, 20, 7 times 20. So that's equal to 140 squared. I can also evaluate this because it's easy number. 14 squared, what is it? 14 squared is 196. And 10 squared, it is 100. So that is 19,600. That's a perfect square. It's a square of 140. So dot, 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 the smallest value of k, which makes this expression a perfect square, is, what is it? 70. Using the same idea, how about b? Ibrahim, are you still with us? Are we still on the same page or thinking about some different things? Do you understand?
Yes, teacher.
You understand everything?
Yeah.
Very good. So the second one says that 882k is a cube. What does it mean? It means that this 882 times k, it must be a cube number. It means some number cube. And what is n? N is a natural number. Maybe 1, 2, 3, 4, 5, 6, any number, right? Again, to be cubed here, first we need to find the prime factorization of 882. Let's divide by 2. It is 441. Celine, 441, is it a square number?
No.
Are you sure? Is it divisible by 3? Yes, right? Here we have 1, 14, it is 4, 21, 7. And again, divisible by 3, that's equal to 50, 49. Now divisible by 7, it is 7, 7, 1. So actually it's a perfect square, right? 441 is equal to 21 squared. Okay, the perfect number. Anyway, we don't actually need this. I just asked this question. Anyway, so now here we have 882k equals, what is 882? 2, that's equal to 2 times 3 times 3 times 7 times 7. So if you just write this in index form, here we have 2 times, here we have 2 3's, so it is 3 squared times 2 7's, it is 7 squared times k. Now, Ibrahim, what is the smallest value of k that makes this number a cube? That means cube number.
No.
First, we need to have 2 squared, right? What else?
Then multiply
By 3, right? Because if I put
yeah.
3 here, 3 squared, 3, we will have 3 cubed. 2 times 2 squared, it is 2 cubed. Because to be a cube number, here we need to have the cubes of these numbers. And here I need one more, 7. So here we need to have 7, which is equal to 4. 4 times 3, 12. 12 times 7 is equal to 84. Look, if you check this, 882k is equal to 2 times 3 squared times 7 squared. And what is the value of k? That's equal to 2 squared times 3 times 7. Now, if you simplify this, here we have 1, 2, 2 more 2's. So if you just combine them together, here we have 2 cubed. Let me write equal sign here nicely. Times 3 squared, and here we have one more 3. So it is 3 cubed. 7 squared times 7. So here we have 7 cubed. So I can just write it cube, cube, cube. I can just write it as 2 times 3 times 7 cubed, which is equal to 2 times 3, 6, 6 times 7, 42 cubed. So that means that that number will be the cube of 42, which means it's a cube number, right? So the smallest value of k that makes this expression of this number a cube number is, what is it? Here, it is 84. So dot, 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 the value of k must be 84. So that this 882 times k will be a cube number. Okay? All right. Guys, I give you a break for you, okay? 3 minutes, okay? Let me also drink some water. And after that, we will have 50 more minutes and we will finish the class, okay?
Okay.
Hello. Selin Ibrahim, are you there?
Yes,
Yes, I'm
teacher.
here.
Okay. Guys, let's just, this is the last question. Okay, 9 also finished and done. About this question, let's just give you some hint, okay? You think about this, and the next class, we will discuss about this more. It is a kind of question that you may have in Math Olympiad or SASMO. A three-digit number is the product of four prime numbers. Here we have A, B, C, that's three-digit number. P1, P2, P3, P4, these are four prime numbers. Given that the three digits of the numbers are all prime, okay, that means that maybe either 2, 3, 5, 7, actually three of these numbers, and different, and the sum of its prime factors is 30. So since all of these, actually, these are prime numbers, right? So prime factors is 30 means, so either we have P1 plus P2 plus P3 plus P4. That's equal to 30, or maybe three of them, because here this P1 and P2, it may be the same, because given that the three digits of the numbers are all prime and different, and the sum of its prime factors. Actually here, because here, what I mean here is it may be something like this, 2 times 2 times 3 times 5. Maybe it is something like this, 2 times 3 times 5 times 7. Maybe it is something like this, 2 times 3 times 3 times 7. I mean, one prime number may appear twice on the right-hand side. We have no information about this, right? Here on the left-hand side, they are different. On the right-hand side, we have no idea. Anyway, find the number. So actually, since it is 30, what may be the possible values of these numbers? If you write the prime numbers, here we have 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29, for example, right? So 29 plus any three numbers here equals 30. It's not possible, right? So actually this 29 is not possible. How about if one of these numbers is 23, for example, and the other two numbers must be 7, right? Do we have any possibility like this? Maybe it can be 7, right? At the time, our number is something like this, 7 cubed times 23. And how about if it is 19? If it is 19, and some of these numbers should be equal to 30, it should be 11. So what is it? It is 5 and 6. Is it? Do we have any 11? So here we have 11. Maybe it's something like the 11, 19 squared and the 11 squared. So this 19 and this 11, these are the prime factors of these numbers, right? So 19, 11, let me just write like this, 11 and 19, so that our number is 11 squared times 19 squared. Okay, all right. Unstable y. Okay. And how about if it is 17, for example? Let's say one of the numbers is 17. The second number, since the sum equals 30, it should be 13, right? Maybe here we have 13. Okay. Like this, you need to check a few numbers. And after that, what is this? What is this actually? Do we have a number that's all digits are prime numbers, three-digit number? Is it possible? This one is so big number, right? It is more than 1000, so we have nothing here. How about this one? Also this one is greater than 1000. Also here we have nothing here. If it is 17 is 13, it should be something like this, 17 squared and 13 squared. Also that is greater than 999. Also we have nothing to do here. And okay, here that means that here not possible, here not possible, and 17 also with 17 we have not possible, right? And how about if it is 13? If it is 13, for example, and it should be 17, 11 plus anything. Can we get 17 here? 11 plus 7, no. 11 plus 5, no. 11 plus 3, no. So also 13, we have no choice. How about if it is 11? It should be 19. Okay, like this, you need to have a look. Okay, that let me just stop because it's taking a long time. And have a look and think about this question. And we will discuss this maybe in the next class. And also I will think about some different ways how to solve this one. Okay, there must be shorter way. Okay, Ibrahim, that's all about the first chapter. Now we will start the second chapter, a few things, okay? And second chapter is about integers. And also you need to practice the question from A1, okay? That much is enough for chapter 1. Let me close this. This question 10, Salim, try this yourself, okay? And also next time, remind me, we will discuss this more. That's all from this chapter. We have just 5 minutes left. Let me just start, okay? Then we will finish the class. Okay. Chapter 2 is about integers, okay? So that's also not so difficult. Even you practice a lot of these numbers at primary school. The only difference is now here we have negative numbers. So what are we going to learn here? We will learn how to use negative numbers in practical situations. Practical situations means in our daily life situations. Perform calculations with integers. Perform calculations means how do we add two integers? How do we subtract two integers? How do we multiply two integers? How do we divide one integer by another one? Represent numbers on the number line and order them, and use the symbols greater than, less than, greater than or equal to, or not equal to. These symbols. Ibrahim, can you read the first paragraph, and Selen will read the second one and the third one, and I will finish the class after this slide, okay? That's just
Okay.
introduction to integers.
The concept of negative numbers is divided.
Mr. Kazim, do you hear me or no? You're lagging. I'm gonna join from phone.
Okay. Ibrahim, continue.
Negative numbers is divided from many of our life situations. Here are some we normally record the temperature Teacher, I can't see the screen now.
Really? Okay, just a minute.
One minute.
How about now?
Now I see.
Okay.
10 degrees above 0 as 10 degrees and correspondingly I no,
Okay, Ibrahim, let me, Salim, you continue. The second paragraph, we normally record the temperature 10 degrees Celsius above zero as 10 degrees Celsius, right? And correspondingly, we record the temperature 10 degrees Celsius below zero as minus 10 degrees Celsius. Salim, read the last paragraph.
Sea level is usually taken as a zero altitude. If a bird flies 50 meters above the zero altitude, we use 50 meters to represent how high the bird is flying above sea level. Correspondingly, if a submarine dives 50 meters underwater, we'll use negative 50 meters to represent its depth below sea level.
Okay. Guys, let's stop here, okay? And after next time, we will continue from here. Ibrahim, actually, Salim, you already received. I also going to send questions from about integers. Have a look. As much as you can, try to do those questions. If you cannot, just wait. After this class, you will do those questions, okay? Guys, that's enough for today. Just continue doing your assignment. Okay, see you on Wednesday or
Yes,
when we have
I'm
class?
already finishing the
Thursday.
homework with integers.
Thursday. Okay. Okay. Bye-bye. Okay. See you on Thursday.
Goodbye.